Have you ever wondered where exactly that segment starts and ends and whether or not that's important? Well, let's talk about that today. There have been lots of discussions about the endpoints of our segments and whether the companies are reporting them accurately. I wanted to delve into this a little bit further and find out how accurate those endpoints are. Now, in order to do this, I have to have the same DNA that is being looked at by different companies. And it just so happens that I have tested with 23andMe, my brother has tested with 23andMe, and we both have that data not only on 23andMe, but also on GEDmatch and on MyHeritage. So I can look at 3 different companies and see how they're interpreting this exact same data. Now, if I look at 23andMe, this is what me and my brother's first 12 chromosomes look like. And at MyHeritage, it looks like this. And in GEDmatch, it looks like this. Now, if this is all we were looking at, we could go back between them and say, yeah, there's some things looking the same, and we might notice that there's some things looking different. So let's focus in on chromosome number 1, and we're going to blow up these 3, put them right next to each other, and try to decipher what we see that is the same, and then we'll get into the actual numbers. Now, as I am looking at this right here, what I can do is I can go through and I can count these segments. Now, if you'll notice, GEDmatch and 23andMe, they actually are reporting the full identical as well as the half identical. We're just worried about the half identical. So I can see that there is 1 segment there, there's 2 segments there, there's 3 segments there, there's 4 segments there, and there's 5 segments there. But if I go down to MyHeritage, I see a 1, I see a 2. There is this break right here across the middle of the chromosome that has split up what 23andMe calls a 1 segment into 2 segments. So MyHeritage is actually showing 6 segments as opposed to 5 segments. Now, if I go down to GEDmatch, I see 1 segment here, 2, 3, 4, and 5. So on chromosome number 1, again, I'm just looking at 1 chromosome. I can already see that there's going to be a discrepancy because MyHeritage calls 1 segment 2 different segments. And part of that is considered not a match. And that's just because of the way that they have analyzed it. Let's go and let's take a look at some actual numbers and see what we can see from these numbers. So I've divided this up into each of the 5 segments, and you'll notice that there is the 3B for just that MyHeritage. And we'll take a look at that in relation to the 3A one as well. Starting on segment number 1 of chromosome number 1. If we're just looking at the start position, we can see that they vary. There is 9,003,178 from GEDmatch, but 23andMe says it's 9,076,000, and MyHeritage says it's 9,132,000. So there's about 130,000 position difference just in that start position. The end position is anywhere between 30.804 to 30.920. So again, about 115,000 difference in the ending position. And as we actually look through this, it is not consistent which one is always, or which one is the high and which one is the low. For instance, GEDmatch here is the low. If we go to the second one, we can see that GEDmatch is the low. Third one, GEDmatch is the low. Fourth one, GEDmatch is the low. And fifth one, GEDmatch is the low. So we might think GEDmatch must be the low all the time. But if we look at the end position, the low number is 23andMe. The low number here is 23andMe. The low number here, we'll skip this one because that's the double one. The low number on number 4 happens to be 23andMe, and the low number on the 5 is actually a tie between GEDmatch and 23andMe. Although this segment looks like it goes to the end of the chromosome, so that may be why those two numbers end up the same. If we look at the highs, we'll also see some difference. Let's change the color to green to look at the highs between this. So the high here is MyHeritage. Down here though, that high is 23andMe. And then the high is 23andMe. Our high here is 23andMe. Our high here is 23andMe. So 23andMe, except for that first one, which was MyHeritage. On the end position, the high is MyHeritage. The high here is actually GEDmatch. The high here on number 4 is GEDmatch. And the high here is MyHeritage. So there's not necessarily a consistency between these. If we also take a look at the Centimorgans that each one of these segments is being called, we can see that there's a wide variety. For instance, between the high and the low, there is about a 1 centimorgan difference on this first one. And the high and the low here, there's actually 1.6 centimorgan difference. And on number 4, there is a 0.9. So this is actually closer. And on this last one, there's a 1.5. So there is quite a bit of difference between each one of these and what they're being called. Finally, on the SNPs that are analyzed. Now remember, this is the 23andMe data from myself and my brother that is being looked at by each one of these companies. So the actual SNPs that are on it are the same. The question is, what are the companies actually looking at? And this is what I found actually most fascinating. And I'll show you why. If I look at 23andMe, in other words, the company that did the testing, they say that in this segment, they're looking at 4,000 SNPs. But let me highlight that there. But MyHeritage, when they look at the same data, says that they are looking at 12,000 SNPs. That's a big difference. They're seeing 3 times the number of SNPs that what 23andMe is. Now, GEDmatch only considers 1,500 of those SNPs. Again, there's not a consistency between that necessarily. 23andMe for the next one, 1,600 versus 4,700. Now it's about 3 times as much, and only 500 for GEDmatch. On the fourth one here, again, 7,000 to 20,000 to 2,500. Last one, 1,700 to 4,000 to 500. So what it looks like is that MyHeritage consistently is showing 3 times the number of SNPs that 23andMe is, and GEDmatch is about 1/3 the number of SNPs as 23andMe. Now I mentioned in some past videos that 23andMe was one of the original tests that GEDmatch was based off of. Now the difference here is that I had tested with the version 3 chip, my brother had tested with the version 5 chip, and those are different chips, and there's a significant difference in the number of SNPs. So I understand why GEDmatch is not showing as many SNPs as what 23andMe is. What I don't understand is why MyHeritage is showing 3 times the number of SNPs as what 23andMe is. That's something I might have to look into a little bit more and see. So I want to now look at this segment that 23andMe and GEDmatch says is 1 segment, but MyHeritage identifies as 2 segments. So let's take a look at some of the data that we see here. First off, the starting data is right next to each other. It's, varies some by almost 300,000, but it's all in that 76.7 million range. Now the ends are 184, 184, and 185. And so their endpoints for this is very similar as well. What is the only difference then is that we have MyHeritage saying the first segment ends at 121 million. And then there is a gap of about 24 million. And we have the rest of that segment. Now, if we take the CMs for those two segments, it's 46 and 45.6. That is going to equal 91.6, right around 92, which is very close to this 94.9. It's only 3 Centimorgans different, and it's just a little bit more than this 86.7. So what we know from this is whether or not that center part is a match. As far as the overall Centimorgan match for it, it doesn't make much of a difference because of how Centimorgans work. That middle 20 million portion, which overlaps the center part of the chromosome, doesn't matter much as far as Centimorgans. Now, this is one place, though, that we do see a little bit of a discrepancy, and that is between these two, the 23andMe and the GEDmatch, or even the MyHeritage if you add both of them together. If you remember, the Centimorgan difference between each one of the others was only 0.9 to 1.6 Centimorgans difference. This one happens to be almost 8.2 Centimorgans. That in and of itself is a sizable chunk. Why is it that 23andMe and GEDmatch have a different Centimorgan? That's almost 10% difference in the Centimorgan value, even though the start and the end positions are relatively close together. There's not that much difference between them. In fact, GEDmatch actually shows a larger segment by position than 23andMe does, but 23andMe shows a larger Centimorgan by position. What I gather from this, and what I want you to take away, is that the actual start and end positions don't matter so much. And there's a reason why. Let's go over on the whiteboard what that reason is going to be. So if we draw out a chromosome, we are not looking at every single spot on that chromosome. Remember, you have about 3 billion letters on your entire genome. And when you do a DNA test, you're only looking at about 500,000 of them. You're looking at a tiny fraction of them. What we end up with is SNPs that match other people as well as some that don't. So if we say that, hey, this, let me get to green first. This all match. And we look at some SNPs, and I'm going to actually add a couple more green ones there, and we have a green there and a green there. But if we go over to our non-matches and we see that, hey, that doesn't match, that doesn't match, that doesn't match, there's that doesn't match, that doesn't match, that doesn't match, and that doesn't match. From this, we have to figure out what different segments are. So some parts of it are pretty obvious. In other words, hey, this area right in here between these two SNPs, that's got to be a match because everything matches within there. And it looks like we're going to say that this part right here is a match also. Now, if we want to say, well, what's a non-match? Well, there's a few places that it's clear that there's a non-match. We've got this area right here, which looks like it is, this right here, which looks like it is, and this right here, which looks like it is. So then the question becomes, what about these other areas? Because I don't have blue and black bars over this entire chromosome. In other words, let's use yellow for this. What about this area right here? Between this green one that was a match and this red one. Are we saying that's part of this segment, or is it not part of this segment? Because depending on how you count it, it could be either one. Or it actually could be divided somewhere in half. Each one of these segments, the endpoints, basically represent where a recombination happened sometime in your ancestry. And so that recombination, just because of the number of SNPs that we're looking at, rarely is going to be exactly on that SNP. It's going to be in between SNPs. But because of the definition of a SNP, that the SNP is where a difference can take place, or that DNA in between SNPs should be identical for everybody, which means you can't really identify for certain where a recombination took place. For instance, in between these greens, there may not be many SNPs there, but is that a match or is that a non-match? Likewise, what about in between these? Do we know whether it's a match or a non-match? And we don't. If there is too big of a gap between certain SNPs, and they try to minimize this when they're selecting their SNPs to make sure that they're spread out enough that they can accurately identify where segments are. But as things get cut up over time, you're going to end up with some cases where it may not be a match or it may be a match. And so you can't know where the exact endpoint is. Because of the criteria for when a segment starts or ends, in a lot of cases, you don't know which SNP is the start or which SNP is the end. There is usually going to be a couple of possibilities based on the criteria. Because sometimes this SNP that I have right here might have been called incorrectly. And if that SNP was called incorrectly, and that SNP is really a green, then what we end up with is we actually end up with a segment that is probably that long as opposed to much shorter. Whenever I'm looking at end or start positions, I'm not trying to look at the exact position. If we go back to our chart that we had here, I can show you what I mean by that. We can see on this chart that the start positions are all about the same. They're right around 9 million, somewhere between 9 million and 9,100,000. We can see that the end positions here are all between 48 million and 100,000 and 48 million and 200,000. What we don't see is we don't see 48 million for two of them and 60 million for another one. So in most cases, if I'm looking at the start and the end positions, if they're within 500,000, maybe even a million of each other, it's probably all part of the same segment. And each company is just using a different way to look at it. Most likely, if you actually pulled up that exact position, that position would be in between two SNPs. Now, how they are determining that position is based on whatever their algorithm is. And that's why, even though these segments look the exact same, each company is calling their start and their end position a different location. If you'd like to learn about which company I think is the best company, then you can watch this video up here. I update that each year. And if you want to learn something else about DNA, then watch this video down below. Now, if you'd like to learn more about how, no,